In session 108, we're going to continue with solving inequalities. And additionally here, we're not only going to solve them, but we're going to graph them at the same time. So let's go ahead and take a look at our first inequality. X over 3 plus 4 is less than 10, or less than or equal to 10. Well, here's our x over 3. Here's our variable. We need to isolate our variable. Right now it's being added to a 4. So we need to subtract 4 from both sides. Well, after we do that, that's going to leave us x over 3 on the left, because x over 3 plus 4 minus 4 is x over 3. That's going to be less than or equal to 10 minus 4, which is 6. In order to get the x by itself, we have to undo the division by 3, so we undo that by multiplying by 3. Well, after we multiply by 3, the left side would be 3x over 3, which is just the same thing as x. And that's going to be less than or equal to 6 times 3, which is 18. So x must be less than or equal to 18 in order for this inequality to be true. Well, let's double check and put our 18 back into our inequality here. 18 over 3 is 6. 6 plus 4 is 10. Is 10 less than or equal to 10? Yes. And it's telling us that we need to be less than or equal to 18. Let's choose another number now for x that's smaller than 18. Let's choose the number 3. X is 3. 3 over 3 is 1. 1 plus 4 is 5. Is 5 less than or equal to 10? Yes. So the correct answer to this inequality is that x must be less than or equal to 18. Well, let's come down here and take a look at our graph, our number line I should say. That's points 0, 10, and 20, and the halfway point between each of them is going to be at the 5 spot, so that'll be 5 and that'll be 15. What we're wanting to do here is stick the solution to this inequality by graphing it on this number line. So I'm going to come up here and find 18. Let's see, it's about right here. Now, is this less than 18 or less than and equal or equal to 18? It's less than or equal to. So that means that I'm going to use a closed dot. That tells me to include that point. And it needs to be less than from this point forward, less than 18. So I'm going to go left because going left on the number line makes it smaller. It goes in the negative direction. So this graph right here, this is point 18. It has a closed dot, which means include 18 as a portion of the solution here that's being graphed. And then you move left. Everything to the left of 18, including 18, will give us a solution to that inequality. Let's take a look at another example here. X is less than or equal to x plus 4, which is less than or equal to 3x. Here we have a variable in each of our 3 slots here. And what we need to do is to solve this for x. And in order to solve it for x, we've got to get x all by itself in one of these slots, one of these 3 slots, so that we can then get a subsequent inequality that we can then use as our solution and then also use for graphing purposes. Well, if we take a look here, we have a 1x in our first slot. We have another x in our second slot, but we have 3 x's in our third slot. What do you think we can do in one action here, one mathematical operation that'll get rid of 2 of those for us? We could actually subtract x from each of our 3 positions here, each of our 3 slots. So let's go ahead and do that. Let's subtract x. Well, what's x minus x? Well, that's 0. So in our first slot here, we now have a 0. And that's going to be less than or equal to x plus 4 minus x. Well, x and minus x cancel, so that just leaves us with a positive 4 there, which is less than or equal to, what's 3x minus x? Well, that's 2x. So the first step in this problem was to subtract x all the way across from each of the 3 slots. That then leaves us the inequality of 0 being less than or equal to 4, which it is, which is less than or equal to 2x. We still need to solve it for x. X is not by itself yet. It's being multiplied by 2. So to undo that multiplication, we need to divide by 2. We need to divide each of these 3 slots by 2. Well, 0 divided by 2 is simply 0. That's going to be less than or equal to 4 divided by 2, which is 2, which is going to be less than or equal to 2x divided by 2. Well, 2x divided by 2 is just simply x. This right here is the final inequality solved. 0 is less than or equal to 2, which is less than or equal to x. This right here, x is greater than or equal to 2, or another way of reading that is 2 is less than or equal to x. This statement right here is the one that tells us the most about x. X just simply needs to be greater than or equal to 2. Because by definition, if it's greater than 2, it'll also be greater than 0. That's our solution. X must be greater than or equal to 2. Well, let's try it back up in our original. Let's put a 2 in here. If that's a 2, here 2 plus 4 would be 6. And 3 times 2 would be 6. Is 2 less than 6? I should say, is 2 less than or equal to 6? Yes. Is 6 less than or equal to 6? Yes. Now let's choose a number that's bigger than 2. Let's choose a 10. So what I'm going to go ahead and do here is erase these. And this time we're going to select a 10 and find out what our values are, because 10 is greater than 2. Well, if we put a 10 in, there's our value there. 10 plus 4 is 14. And 3 times 10 is 30. Is 10 less than or equal to 14? Yes. Is 14 less than or equal to 30? Yes. So we've just double checked that in fact x greater than or equal to 2 is the solution to this inequality. Well, let's come down here onto our number line. What we're trying to graph is x is greater than or equal to 2, or 2 is less than or equal to x. They both say the same thing. Well, the fact that it's less than or equal to means we're going to use a dot, a closed dot. And x needs to be greater than this 2, or equal to it. So we're going to take our number line to the right, because the right direction on the number line takes us in the positive, into the greater than direction. This then is the graph of the inequality x is less than or equal to x plus 4 is less than or equal to 3x. The solution to that inequality is x must be greater than or equal to 2, and then here is the graph of x is greater than or equal to 2. Lastly, as a review, if you have the same variable on both sides of an inequality, or as in the example we just looked at, it was in all 3 sides of the inequality, make sure that you get it remaining in just one side of that inequality, which is just what you try to do with normal algebraic equations. Isolate the variable all by itself on one side. Okay, that'll finish session 108.